Hello, welcome to Factorio. My name's Carter. I'm going to give you a little overview of a really cool 6,000 science per minute base that I've been working on for the last couple of weeks. It runs entirely in vanilla, which I'm demoing now, but I did use a few interesting mods while building the base. But then I turned all the mods off to sort of demonstrate that the entire base runs without any mods whatsoever. Those were just sort of quality of life mods and a few things like editor extensions, which I'll get into in a minute. I wanted to do this base to really highlight some of the new Factorio 1.1 features that are out, like the train limit and the blueprint flip and some other features around blueprints, like the fact that electric wires can be stored in the blueprints. And then I wanted to just set some interesting constraints for myself. So first off, no bots whatsoever. There's not a single robo port in this entire design. I used them during construction, but then I removed them all, and my entire base is running without bots. There are no large belt balancers. So I use belts, obviously, but there's no balancers, at least no big ones. So the entire base is sort of a parallel 16-way design that I'll get into in a minute as well. And then I also turned off biters, which I never do. I'm usually a big fan of keeping the biters enabled, but I wanted to try something different. So focused more on the creativity and the artful side of things, and turned off biters, which turned out to be kind of a fun way to remove a constraint from the game. And then I focused on something else. But I don't normally do that. I'm usually a big fan of biters. In fact, I kind of like the Death World settings and that kind of thing. So anyway, just something different for this base. I designed the entire base in reverse. I was inspired by Nilaus's reverse Megabase series, which I'll link to in the description below. I thought that was a really cool way to design things. His series is going on as I build this. I only watched the very first episode of his series and then got the inspiration for this design. And I actually have no idea what he has done ever since the first episode. I've purposely not peeked at his work to kind of see what he's been doing. And I wanted to keep this design entirely my own, but I really liked some of the things that he did as the initial setup. So I basically followed the same things he did in the very first episode of that series, which I would encourage you to check out. He used the editor extensions mod by Rayguard, which is a really cool mod. It allows you to magically conjure up materials onto belts, pipes, chests, and cargo wagons, and that kind of thing, and also produce an infinite amount of power and basically allow you to produce materials wherever you need them in whatever way you want in an infinite way. And then you work backwards. So the way I did this was I started with all of my labs here, and see these little underground belts here. I made those editor extensions, little purple underground belts, which just infinitely produce a half belt, in my case, of white science per underground. And then just made sure that the labs, in fact, could soak up 6K science per minute and run at that rate, and they did. And so then I worked from there. And so I built train stations around it, and then I made the trains actually go to real bases where they build the actual science, construct the actual science, and then turned around and fed them back into this and made sure that the whole thing kept running. So the entire time I've been building this base, it's been running at 6K, which I think is a really cool way to do things. I've never done it before, so thank you, Nilaus. That was a cool idea. I guess while we're on it, I'll talk about the mods that I did use. I used editor extensions, like we said, and I used one called Factory Planner by Terraness, which is a really cool way to completely design all the little ratios and everything for your base before you start building. So you can figure out exactly how many assemblers you're going to need, how many inserters you're going to need, figure out if there's any throughput issues around belts or inserters and that kind of thing. And I made pretty extensive use of that. In fact, I made very extensive use of all the ratios in this game. I really wanted to concentrate on the mathy side of this for this build. And so I designed everything very tight and close to the wire. Anyway, just really liked the ratios and the designing of things in this build. And so thanks to Factory Planner for making that possible. I used one called Automatic Train Painter, which I could have manually painted all these trains and set their colors. But why do that when there's a really cool mod that basically just looks at what materials the train is carrying and then sets the train to the right color accordingly. And then once you've done that and gotten all your trains to run once, you can disable the mod and all your trains just stay that color. So that's what I've done here. And then I used a few other quality of life things: squeak through, long reach, FNEI, even distribution, automatic research, just so I don't have to continually queue things up. Now that I'm on mining productivity 219 and all my technologies take on the order of 542K or more to produce, well, at this point, it doesn't really, I mean, it takes an hour, several hours to produce, at 6K science per minute. That's many hours before I run out of one research. But when I was first starting this, there were a lot of different ones that I was going through. And so to constantly remember to have to get into that thing and queue up lots of science research was tedious. So I used automatic research. So thanks to that. All right, so let's get into this base. Let me give you a little overview of the whole thing. First of all, there's the labs. And the labs have this really cool little design. And I wanted to really build an entire base that was focused around powers of 2. And so everything in this base is built around the idea that there's 16 parallel inputs to every production chain. So there's 16 sciences coming in. There's 16 all the way out to the edges. And I use 2 16-2 trains everywhere in this base, except for a few 1-1 trains to carry fuel and things like that. And so the idea of powers of 2 is pretty significant in this base, as is symmetry. I really wanted to do everything square. Like I said, I was inspired by Nilaus's base, and he had a 3K science build that was 8 by 16. And I thought, well, I mean, if you're going to go that far, why not make it just a square and go 16 by 16? And let's take it from there. And so let's zoom out on the map and take a quick look at the base. First of all, there's a grid block for my labs, and then there's a whole grid megabase all the way around it, and everything is a square within a square, sometimes within a tilted square, sometimes a tilted square within squares, and so forth, all the way out to the edges. And I think this came out really nicely proportioned, and everything is symmetrical, and everything is running at 6K science per minute continuously. If I pull up the production here and look at the last hour or whatever of science, what am I looking at? Looking at green science. For the last 10K, it's been very flat at 6K. There's a few blips back here. I think I was just changing out which science I was doing or something. And if I zoom way out and go all the way back to 250 hours or whatever, I've been working on it since this started right here. And you can see I just started with it working at 6K, and then I would tear things up and make something new work, and then keep going, and then tear things up and keep going, and so forth. And basically, ever since the last major couple of changes I made, it's been running at 6K science per minute the entire time. And that's a real testament to this idea of the reverse megabase. So I think this is a cool way to build things. Let's talk a little bit about the city block design. I didn't use Nilaus's 100 by 100 block design, even though that's very popular, and it works nicely. It fits with roboports and so forth. But my base has no roboport, so I don't have that as a constraint. Instead, what I used was the idea of these trains. So these trains are 2 16-2, and they're this long, and they need a little bit of turning room to be able to fit. And so I designed everything within a chunk-aligned grid. If I turn on the show tile grid in the debug settings, I just hit F4 to pull that up. You can see everything is aligned here with the grid. So the grid itself centered, and these are 9 by 9 chunks to these intersections. But then the real meat of the matter is inside of these 7 by 7 chunks, which is the inner part of each grid. And that's where I had to fit all of my designs. So every single one of these fits inside this 7 by 7 grid with an extra tile outside for the rail network and for a little bit of routing to get things to and from. But like you can see in this one, it's just a 7 by 7 grid right here, and all of the interesting stuff is happening inside of that. And so that's just as small as it can be in order to support these trains, and just as big as it needs to be in order to be able to actually have this much science produced in a really compact way inside of each grid. And so let's take a look at some of these builds. Let me just take a look right away at one of the more complicated ones, just so you get an idea of how this works. This is purple science. Oh, I'm going to turn off the grid. That's a little annoying, right? I spent a lot of time staring at it, so my eyes are almost used to the idea that that's just there. Useful, but kind of ugly. Okay, here's purple science. The idea is that there is a center station, the train comes in, and both sides load directly into the trains. And so I've got these 8 beacon builds right here where everything for purple science is produced on one side. And then I used the blueprint flip feature in order to be able to flip this horizontally and produce a symmetric side on the opposite side. And then all of the materials are brought in via train on the right side here, or left, but they're brought directly in. There's no balancers. There's none of these belts that sort of carry from trains into this production area. It's all very tight and compact. Train to production, back to train. And this was a real challenge to build. You can see that I had to line everything up with the beacons spaced every 7 tiles, because that's the size of a cargo wagon. And then that leaves only 4 tiles between the beacons in order to put all of your production. And so in some cases, this was a real interesting puzzle to try to put together. So like this one, I had to do some belt balancing or belt weaving in order to feed all the rails and other intermediate materials over to the purple science assemblers over here. So like I said, this is one of the more complicated builds, but yeah, I think it really demonstrates the concept here, which is that you bring in these source materials, and then each cargo wagon is completely parallel. So there's no communication or transport of materials between this cargo wagon, say, and the next one down. And so it's completely parallel. These materials produce this purple science. These materials produce this purple science, and so forth. And except for the fact that there's a little bit of sharing from the left and the right side, but other than that, they're completely parallel. And even that, because they're producing essentially all at ratio all the time, there's really not much imbalance that's produced in this space. I'll talk a little bit about how I deal with imbalances later, but I've run this AFK for hours and hours and not run into any imbalances that are very significant. And I think that's a testament to like the tight ratioing that's produced here. So I really like this build. I think it came out really well. Let's get an overview of the base first. There is one major ingredient produced per grid. I've got a little tag showing what's being produced in each one of these. So like this is producing steel, this is producing plastic, this is producing yellow science. All of the sciences are built in these 7 locations around the spokes. In fact, they're concreted in. You can kind of see them. They have a little bit bolder design. I do think that was Nilaus's intention as well, to build around the center lab hub. I saw that far into his base, but other than that, I really don't know what else he's going to be doing. Anyway, I took that idea. I thought it was cool. And then I came up with, I think, a pretty cool placement of all the other materials. So I've got 3 iron smelting areas, 4 copper smelting areas, which are around the sort of corners of this cross. And then I've got 5 steel smelting blocks and 2 green circuits, 2 red circuits, 1 blue circuit. Got LDS over here, plastic, like we said, rocket fuel, satellites, and then rocket silos up here in order to launch the rockets. Hey, I'm sure you're curious. Let's take a look at that. So here we are at the rocket silos, and you can see that trains bring in materials completely in parallel. And in this case, 2 cargo wagons are going to feed each of the 8 rocket silos. And then there's a circuit down here, timer circuit, that's advancing. I've sort of got lights here just to sort of let you see how far along the countdown is. And when this gets all the way up to here, it will launch a rocket by inserting the satellite into each rocket silo all simultaneously. And so you get a nice simultaneous launch. I've got some circuits to make sure that there is a backlog of materials at all times. And if there isn't a backlog of source materials, it won't insert the satellite. And that will make sure that there's always either a launch or not a launch. I don't want there to become any imbalance at the rocket launchers here. Sorry if that's a little loud, but it's always fun to watch the rocket launch. So let's hang out and watch this happen. It's so cool to hear them in parallel. You get that like reverb. So satisfying to see a parallel simultaneous launch. I love it. And then they fade out into the distance as they do. So while we're here, let's take a look at the smelter. The smelter is a pretty cool design, I think, and pretty typical of the rest of this base. You end up with a cargo wagon producing all of the inputs for a row of these furnaces, which then produce, in this case, up to here, half a belt of copper, and then the other side produces the other half a belt of copper. And so you end up with just over, actually, in this case, you produce a belt and a half of copper. That's sort of how this works. So there's a half belt down here, and then a half belt here, and then it's flipped sides, and then this produces the other half of the belt. And so all told, you end up with a belt and a half right here, which just happens to fit really nicely between the trains and fits nicely ratioed out within the designs of the base. So I've got 4 of these smelting blocks, and that's just about exactly what's necessary to run the 6K for the base. You can see that the basic design is that there's an output station down the middle, and there are input stations on either side, each with a waiting area. In this case, I kind of have inline stackers on the top and the bottom so that a train can wait. You'll see that some of the other blocks that I've got have a slightly different design, and we should talk about that in a little bit. In order to deal with any imbalances that arise, I've got circuits on each of these chests. So this F signal is produced anytime these chests are completely full, which they are right now. And then this L signal is produced when whenever the chests all add up to about half full. And I can vary that threshold around, but I usually use about half to indicate my L signal. And so the idea is that they should either all be full, or either not full or not low, or all low. And if I ever see a situation where some of the trains are full and some of the trains are low, then that's a bad thing. And the way I do that is I just take F, which is how many trains are full, and I multiply it by L, which is how many trains are low. And if that number is ever non-zero, then I've got a problem. And I do 2 things. I sound an alarm, so I've got this little programmable speaker here, which will sound an alarm if that ever occurs. And then the other thing is that these train stations have an extra condition. They're normally just saying, go to the ore until it's full, and then come here to the smelter until it's empty. But then there's also this other thing, which is or the circuit is greater than 0 and 30 seconds have passed. So this is sort of an escape hatch that if there ever is an imbalance, the trains will get out of here early and turn this volume alarm on so that I can notice that the problem is occurring. And I've been running this base for hours and hours, and I haven't run into this but a few times. But this allows me to AFK for a very long time and not have any worry that the trains get too deeply out of imbalance. At least everything will keep running. And those particular thresholds of about half full are sufficient to let this kind of run AFK and never run dry. So even if there is an imbalance, the entire system will continue to run pretty much as normal. And we're looking at an imbalanced circuit here built into a pretty low-level material. So this is producing plates from ore, but it continues its way up. And so the idea here is that even if I'm producing something like rocket control units, well, they may have an imbalance, and then they go off and they go produce an imbalance. If the train leaves early, then it'll produce yet more imbalance at, say, the red circuits, and then that'll produce more imbalance, and that'll go down to the green circuits, and then that'll produce more imbalance, which will go all the way down here to the copper or whatever. So you end up with this little cascade. But in practice, it happens very rarely, and it's more just an escape hatch for myself, which I'm appreciative to have, and it was helpful during design. I found a few little missing problems every once in a while throughout my base, like a missing productivity module or something like that. It's frustrating, and it's nice to be able to have something like this to be able to find those imbalances and source them out. Over here, we've got satellites. Satellites are kind of fun. They're its own little city block just to produce satellites. You can see in this case, there's a lot of input materials, but not very much of each input material is needed. So this entire 16.2 train is just producing a half belt. So this train will end up sitting here for a very long time as it finally unloads a half belt of, say, rocket fuel or LDS or whatever. In the case of green circuit, it is quite a bit, but it's just 4 belts worth, and it's just being produced via this unloader here. And then they go down and produce these rows of the source materials to make the satellite. So I produce the solar panels and accumulators here on site, and then the few other ingredients that are going to actually make the satellite. This is one of the places in the system where this little train is just a small 1-1 train carrying some satellites from the satellite build back over here to the rocket station. But for the most part, everything else is 216.2 trains. Let's talk a little bit about the solar panels. This entire base is solar panel driven. And so there are, let's click on a power pole and see. There are 994,000 solar panels and 833,000 accumulators. And if you divide those two numbers, you get 1.19 something, which is exactly 25 to 21, the optimal ratio between solar panels and accumulators. You can see it charges using 60 gigawatts of power during the day, but then discharges at night through the accumulators. So that's 40 gigawatts of continuous power and 60 gigawatts of charging power during the day. And using that ratio 25 to 21, that's just enough to sort of create a perfectly continuous 40 gigawatts of power. I like this design. It fit really nicely into these diamonds, which I have exactly 12 of. And it produces a nice symmetric design, which I'm really proud of. Let's talk a little about the mining. These resources over here are fed directly into trains. I cheated these resource patches to fit the size of my train. And you might think, oh, that's kind of cheating or whatever. And it is slight cheating, but if we wait just a second, we'll see a train come, and you'll see how quickly these trains fill with this mining productivity that I'm already at, and all the beacons and speed modules that are in there. If I click on this, you can see that this train's just filling up pretty freaking fast. And that has nothing to do with the cheated ore patch. The cheated ore patch is just here to make it convenient so it doesn't have to stop at multiple places in order to fill up an entire train, and also so that they can be placed in this nice symmetrical location. I mean, I could have run these trains out over here and put them in series to have a couple of different stops just so it could fill up, say, the first quarter of the train and then the next quarter of the train and so forth. And it wouldn't take very long to do that, but I didn't want to spend a lot of time doing that. I was happy designing this base using some slightly different techniques. And since I was already using Rhaegar's editor extensions mod, I figured, let's try this. I've never cheated ore modules before, and it frankly was such a minimal part of this design that I don't feel bad about it. I think it's fine. I've also got coal doing the same thing, and oil doing something rather similar. Just a whole bunch of pump jacks feeding into fluid wagons that come and pick up the oil. And so all these materials are out at the corners. And to me, this really demonstrates the idea that, hey, the trains really do have to go out, leave the base. It sort of proves to me that the throughput of the base itself and there's no train bottlenecks for resources or anything like that. Let's talk about the train design. I think it's pretty obvious that this intersection is an important part of the design. There's these 8-way intersections throughout the base, and I think they came out looking really cool. They're built around a roundabout, which I don't normally use because they can have throughput issues. They're well signaled, they're perfectly signaled so that you can have as many trains fit through as possible. So like if you have a train coming in and turning and a different train coming in and turning, you could have up to 4, maybe even more trains all at once using the roundabout. Obviously, if one is making a 270-degree turn or something like that, it might use most of the roundabout. But in practice, because these trains are so long, I don't find that these intersections are very much of a bottleneck. So maybe the heaviest usage bottlenecks are these right out here where the resources come in and out. And even they, I mean, if we just kind of hang out and watch, there's really not that much usage. I mean, yes, they come in, they leave, they use the intersections, but there's nothing queued up. And here's an example of, because it's perfectly signaled, they can pass each other right through the intersection and there's no issue. So I rarely even see slowdown at the intersections. Actually, here's one where they is slightly slowing down because this guy has to wait. All of these input areas have a place for 2 trains. So even if that train were waiting here in order for this to go through, yet another train could get out of the previous intersection and come wait next to it here. And I find with that amount of queuing and this size of train that I've had no train bottlenecks whatsoever in this base, and I've been running 6K for many hours, and trains haven't been the issue. Let's talk about some of the complicated places where trains are used, like this plastic area. I really like this plastic design, but it was very tight to fit into this 7x7 chunk. So much so that I had to build some stackers outside of it into this area where I would normally have the siding areas. So this particular block was so tight that I had to use up a few areas around it, but not so much. And I actually think this design came out really beautiful and really interesting looking. It's almost like a little mandala. It's kind of an ode to the power poles as well. I really like how these X's looked and everything. It's really cool. And it's entirely in parallel. Like while we're here, let's just talk out this design. I've got crude oil coming in on the bottom, and then I've got coal coming in on the sides. And those are the 2 ingredients needed to make plastic. And the oil is going through these refineries here, which then go through crackers here and get it all down to petroleum. And you can see this is quite a puzzle of pipes here, which was necessary in order to fit all of this into a tileable area that fit between these beacons. In this case, the beacons are tight not because of having to line up with cargo wagons, but just because they have to be this tight in order to be able to fit around the chemical plants. And so I really like this design. I think it came out about as tight as one can possibly make it. And it's all ratioed so that everything is running like 100% of the time. And if every single one of these columns here is producing a pipe worth of petroleum, which then goes up here and feeds one of these sides of plastic, which is also fed by a belt of coal. And this whole thing works out very, very favorably. And I've got all these little splitters. So I've got, again, a belt and a half, much like my smelters. And that is just enough to be able to be carried by all of these inserters into these chests. And it all keeps up with the throughput needed. It took me quite a while to find a design that was going to be compact enough to fit right up against the trains like this, and also to have all of the source materials like this fit entirely into a 7x7 block. So working out those puzzles was a big part of this particular playthrough for me, and I'm really proud of this design. The water comes in directly from a lake, which is just conveniently located nearby, and I just chose that. While we're here, let's talk about this. I've got a green belt around my labs. I actually used this green belt during the design as waypoint places where trains could go to pick up intermediate materials before I had actually built the corresponding grid block. So, like I said, at the very beginning, I was doing this in reverse, and I just had the labs. Well, then I went off and had them produce the various sciences, but then something like red science would need iron or whatever. And so I would just, in this green space area, produce an area where iron could get picked up. And then I would come up here and build the red circuits or whatever. I didn't do it in that order. I went in reverse, but you get the idea. I would build something and need more materials, and then I just had another area down in here. And then once I had the entire base up and going, I didn't need any of the scaffolding anymore, and so I was able to remove it and create a nice, cool green space for myself. And in this green space is my original crash landing, which I left as an homage. I thought that was kind of cool. So let's talk a little bit about how stackers work at most of my builds, especially the compact ones like this. So here is an input being provided in the form of coal, and this is a station called coal for plastic, and it has the train limit of 1. In other words, only one train can go to this station at a time. Even though there are, whatever it is, 4 different trains that use this station, only one of them can go here at once. And so then the question is, where will it wait prior to coming to here? Well, if I look at the schedule for these trains, all of these trains have this kind of schedule. They go get the coal, then they wait at an explicit stacker station, and then they come here to where the coal is dropped off to make the plastic. And so you'll notice there's no wait condition at the stacker. It may just roll right on through it. But because of the train limit, they may end up waiting there until this coal for plastic station is free, and then it will leave the plastic stacker and come to here. And the advantage of explicitly naming these stackers like this is that they can be placed wherever you want nearby. They don't have to be part of the dedicated track leading up to this station. So in the case of these plastic stackers, they're just like this one right here. Here it is right next to it. Probably this one will be used for the station over here, and these over here will be used to wait for the one on the other side. But they don't have to do that. The point is that they just wait here close nearby until they're needed. And that way all of the track in the middle, including all these intersections and everything, can be shared for lots of things. This plastic can leave, and these other materials can roll right on through. And these stacker stations are more just like waiting areas that are nearby. And I think this ended up being a very clean, elegant design that was very compact and allowed me to really avoid building dedicated track for stackers. Instead, it can be stackers kind of just located conveniently wherever nearby. I've even got these ones called output stackers, which are special stacker stations that are basically here in order to wait to come pick up the output plastic that's needed. And so it's a similar sort of thing, like the different materials that are needed. Sometimes, like plastic in particular, is in very high demand by multiple different other grids. And so you want the trains that are wanting to come pick up plastic to also wait nearby here to the plastic area. So I have these outstacker stations, which serve a similar function to the other ones. I didn't normally name them differently like that, but plastic was kind of a unique circumstance, so I named it that way. I think these explicitly named stacker stations, along with the trade limit, is a really, really clean design that works really well and allows you to create something really intelligent using the minimal tools that are built into vanilla Factorio now that we're in 1.1. I guess there's really only one more thing to talk about, and that's the refueling stations that are just sort of created throughout here. There's these little tiny stations. They also have a train limit of 1, and they're enabled and disabled based on whether or not they have enough fuel nearby. And so if this chest of nuclear fuel gets lower than, I think the threshold is 4. Yes, right here. Threshold less than or equal to 4. If we get down to 4, then this station will become enabled, and a nuclear fuel train will swing over to here and drop off some nuclear fuel to top this up. I just have these little belts of fuel for the various places that need it. And I just kind of selectively decided where I'm going to put them. And so there are no refueling depots that the trains all have to go through. Instead, the fuel comes to the trains. It was a lot easier to add in lots of these little train stations with belts than it was to add in a depot and have to deal with all the extra train routing and have to deal with all these long trains. So having a series of small little wieldy small trains to take fuel to the large trains turned out to be, I think, a pretty clean design in this case. And then all of them come from this one place over here. This is my nuclear fuel setup, which I think is actually a really clean, nice Coverex build. There are these compact lines that bring in a belt of uranium. And this whole thing is totally overbuilt, but it's designed to take a continuous belt of uranium at all times, which early on was needed. But now that I'm full up on uranium-235, I don't need it anymore. But for a time, I was using a full belt of uranium. And then a half a belt of rocket fuel. And I think this is a really cool little Coverex build. Really compact, really neat, fully 8-beaconed. And I think the characteristic feature of this is that I use these yellow splitters here to slow down the feeding of the 238 into the upper belt, and correspondingly 235 into the lower belt. And that way there's always space available for the centrifuges to output, as well as materials available for them to input. And in practice, this works out just great. And it produces something really compact that can be 8-beaconed like this. If you were to need one more tile, you wouldn't be able to fit this in here. And I've seen a lot of different designs, but I've never seen one quite as compact and tidy as this. So, yeah, something else kind of noteworthy. Anyway, I have these series of little refueling trains that come in here and wait until they're needed. And they're just like a little taxi service that takes this out to wherever it's needed. All right. Well, that is my base. I am proud of this thing, and I would like to thank Nilaus for inspiring me. I think this was a really cool idea he had to build a base in reverse. I think I also am thankful that, I looked at his base and thought, hey, there's some things that I could do that I think are up my alley, notably some things with the symmetry and the square 256, i.e. 16 by 16 design that I really like. And I really just kind of took it and ran with it. And I also like the parallel design, 16-way parallelism. I think it produced something really noteworthy. And I really like the compactness of some of these builds. I really like the plastic one, for instance. But it's not just this. It's just the fact that everything is train without a lot of big belt balancers or anything is really interesting and really cool. And for some of these, they end up producing just some very interesting, nice compact designs that I don't think could really get that much smaller and still fit into a design like this. So I think I'm making good use of space. And then it's also just like my first really artful build. I'm really happy with the way this turned out. I think it looks fantastic, and I topped it all off with this cool little light show in the center, which mirrors the design of everything else. So, yay, fractal symmetry. All right, I hope this has been inspiring to you, and that you may go off and build your own cool Megabase. I'd love to see what kind of designs get inspired by this. Take care. Bye-bye.